Okay, this is going to be the platform for my generator project. This is one of those till mowers, and I'm in the process of stripping it down. I elected for this configuration because finding mowers in Arizona is very difficult. This particular one, the engine runs really well, and it's a bit worn, but it does pretty good. And it gives me a horizontal motor that's mounted the way it is, and when I get done stripping all the hardware off, I'll have a platform that I can mount all my equipment to, plus I'll have wheels and a handle to be able to push it around so I don't have to worry about picking it up and throwing my back out. So I'm going to go ahead and start stripping the blades off and all that, and then get down to the bare basics so I can go ahead and start building up the generator from there. Okay folks, this is the parts I've stripped off last night. Most of it has to do with the cutting mechanism and the front axle for the wheels and some of the drive. All these parts are going to be saved because you never know when you might need a chain sprocket, specifically shaped piece of iron or metal. All of it could be useful, so it's going to go on the scrap heap for future research, shall we say. Okay, and this is the stripped down TIF motor, and you can see to the left, the wheel there, there's a C-clamp with a large counterweight on it. Without the machinery in the front, the thing wants to tip over backwards, so hopefully I won't need a counterweight when I'm done, but you never know. So for now anyway, it keeps it in a working orientation. So basically all the jack shafts and belts, drives, things like that are all removed, so you just basically have the engine, the frame, the wheels, that sort of thing. And from here, this platform is what we're going to build the generator on. Okay, here's a little update. As you can see below the alternator, I got mounting brackets. One's drilled and mounted, and the other one I'm getting set to line it up and mark it so I can put a hole in that. You can see the drive belt that's sitting there. It's an old belt. It needs to be replaced, but it's good for aligning everything. So you want to get everything lined up. One thing I suggest doing is, once you get your brackets measured up, is to move them slightly apart from one another, and that way if you have to make a final adjustment fore and aft on the alternator, you can shim it with washers, and that way if you make a slight mistake, you won't be eating up belts, because that way you can move it back and forth slightly to adjust for the angle. Okay, the alternator's mounted, my L brackets are in, and at this point I just need to find myself a new belt and do some more wiring, and that'll come. And anyway, we're well along our way at this point. One thing I'll mention here is that the L brackets are made out of an old bed frame. The steel is forged, it's heavy gauge steel, and it's very stiff, and it works great for projects like this. If you see bed frame rails at yard sales, pick them up. Steel is so expensive that if you were to buy comparable L-shaped steel like this at Home Depot or Lowe's, you would pay $20 for even just 4 feet of the stuff, where you can get, like I did, 6 feet of the stuff 2 times 6 feet 12, and it cost me $5, and I think I overpaid, but still, they're very much worth having to keep in your scrap pile for projects such as this. Okay, I have the new belt on, and as you can see, the linkage here, these are all parts from the machine that I stripped off and I'm reusing. This piece here was a piece I cut and ground down to attach this push rod to, which was the disengagement bar. Here's the turnbuckle adjustment, and there's where it attaches. There's a key holding that on, and it keeps tension on the alternator. So now what we're going to end up doing here is we're going to end up doing the wiring on it, and eventually going to put a bracket down here for battery or tools or anything else. And when you go to start these things, you have to have a switch that cuts the field or the exciter out, and we're going to install that as well. Okay, here's some of the wiring that's done. As you can see, I used lugs you get at Home Depot. Get these in the electrical department. Those guys there, there's 2 of them. This white wire is 6 gauge THHN, and there are 3/8 connectors. Basically, I strip the wire back, slip them in, and take a hammer and pound them flat. And there's wiring up to the switch now to energize the exciter. And I can't wait to try it out, so I'm going to go ahead and hook up a dead battery to it and see how it does. Okay, this is the finished product. It has been running about 5 days, so we'll do a cold start here and you get an idea. You definitely want to have the alternator exciter hooked up to a switch. That switch is located right here, because if you try to start it with the thing energized, you'll be pushing against it and you won't get it going. So once it's good and warmed up, you flip that switch, the energizer comes on and it starts making power for you. Here's the belt guard I fabricated out of expanded steel. I bought that at Home Depot. It cost me about $20. It's criminal, but that's the way it is these days. And they take you around here. This rod here was probably the disconnect rod for the drive system. This part down here, same thing. And come around here. You'll see this in other pictures though, but wiring connections, Home Depot, they're just lugs. You'll see them there. And of course the wiring and such. And the shelf. The shelf is supported by, again, pieces of bed frame. And of course I'm using the original throttle. And what we'll do here is go ahead and start her up, and you'll get an idea just how it vibrates, shakes, and runs. Overall, I'm very pleased with the whole thing. I would do it again. It was a fun little project, and I've already gotten some use out of it.